All right, thank you so much for joining us today. So, in this video, we are going to talk about something that I left before talking about cross product, scalar triple product, and then dot product, right? I should have talking about these guys before we talk about those things, right? But basically, it's also nice to be back. So, scalar multiple, right? Scalar multiplication. So, if you want to talk about this, what will be a is just very simple. We just need to negate this, right? So this is going to be minus a, this is going to be minus 2i plus 3j minus 5k, and this is going to give us minus 2i minus 3j plus 5k, right? Very simple, right? And then b is just 1 over 2a, which is equal to 1 over 2. Then we have 2i, my I and my j are disturbing me, minus 5k. So this is going to give us I plus 3 over 2j minus 5 over 2k. Yeah. And the last one will be c. So let me put the b here and put the c here. So c will be 2 times a, which is just 2 times 2i plus 3j minus 5k. So this is going to give us 4 I plus 6j minus 10k. Right, so this is basically scalar multiplication. If you want to do something like scalar multiplication, then we adjust that. Now, vector addition is basically, we are trying to, for example, if we have something like this, and then we have something like that. Okay, let me put it this way. And then we have something also like this. Good. What are we doing? We are basically saying that let's assume that this is vector A and this is vector B. Then this is going to be vector A plus vector B, right? So vector addition, we can just add two vectors, right? So when I started talking about vectors, and then I should have talked about vector addition and this one before we start. So I wanted to talk about this one. So we can just do this quick example here. So as we are doing, we are adding direction to directions, right? So A plus B, this is going to be minus I plus J minus K plus 2I plus 3K. Right, remember the J here is 0. So this is going to give us this is going to give us I plus J plus 2K. Yeah, very simple. So I'll just leave you with this and this for you to just do it and then put it in the comment section. Right. You see, I'm very good. I always making sure that you two are working some. I'm not doing all the work myself. So you to do for B and C and drop it in the comment section. Let's have some interactions. So let's look at what we are coming to do today. We are coming to talk about equation of the line, right? So when we talk about equation of the line, we started with Math 102, which we're talking about coordinate geometry and calculus. And with the coordinate geometry, we talk about equation of the line passing through a point. Those kind of things we talked about. But this is a vector, right? So we want to look at the vector perspective, right? So we know that the equation of the line is basically in Math 102 is like y is equal to mx plus b, right? This is the equation of the line with in the form of the y-intercept slope, right? Y-intercept form. So this is the slope, and basically this is the y-intercept. But here we want to talk about the equation of the line which passes through the origin. So if it passes through the origin, then there is no y-intercept because that one is going to give us 0. I mean, we know that it is y minus y1 is equal to mx minus x1. So if the point is 0, then this is 0, this is also 0, right? So I'm going to have something like this. y is equal to mx. So this will be the equation of the line passing through the origin and the point, right? So basically that's how it is. So if I have my x-axis and y-axis, basically this is what I mean. Like maybe equation of the line is like this, passing through the origin, and then maybe a point. Let's say we have a point somewhere here, which is B, right? So in vector, we don't talk about this in general, like what we are doing here, like meaning. So what we are doing is this equation of the line here, this equation of the line here is actually parallel to this B because the B is on the equation of the line, right? And when we are saying that something is parallel, then it means that they have the same slope. So the equation of the line, instead of writing it in this form, we are not going to do this. We are going to use the vector position, right? So this is going to give us R, which is equal to, let me use my slope to be lambda, that's the scalar. Then I'll multiply it by, let's say, the vector, which is B, vector B, right? So that's what my equation of the, so this is the same thing. This is like my y is this, and then my slope is this, and my x is also this. You can also write it in the form something like R and then lambda B. It's also acceptable. Any when that you write is correct. So this is the equation of the line passing through the origin. Don't forget, it passes through the origin, right? So basically, that's what we are trying to talk about. So this or that. Good. Now, let me try and explain something here. Now, lambda that we see here, we are going to call it scalar, right? Meanwhile, that is in the sense here we are talking about the slope, but this one we are talking about scalar, right? And then we are going to call this the parametric equation, right? So when you say find the parametric equation, basically this is what we are talking about. We are also talking about the equation of the line. So this, we call it parametric equation. So in this course, we are going to learn how to write a parametric equation. We are going to learn how to write in the form of symmetric, and then in the vector equation. So three of them, three different things that we are going to learn from here. So please, this is very important to have it in mind. Okay, let's look at this. The equation of the line not passing through the origin, but passing through a point A and parallel to B. So basically, that's what we are talking about. It's parallel to B. So it means that here we are going to have equation like this, something like this in this form, because it is not passing through the zero. So it basically we are thinking that our slope equation of the line is something like this because it does not pass through the origin, right? So the equation of the line, we are going to have something like vector this is equal to, so passing through the point A, right? It's passing through A. So A plus lambda and B, right? So this is what I have here, and this is my y-intercept, and this is that. But we are not thinking like Math 102. We are not thinking like coordinate geometry. We are thinking like a vector algebra, right? So we are here. And this one too, we can write this one as R, which is, let's say, A plus the lambda, and then this is my B. So we can also define B, and so the same thing, lambda is the scalar. Now this B here, we call it the position vector, and this one is the parallel. So you will see that there will be a question that you have this equation, but the only thing that we need from this equation is the B. Yes. So we will learn all the tricks whilst we are going through. But before we move, what you need to remember is the formulas. Very, very important. So let's look at something here. This is what basically we are doing. So I have my y as x, I have my x-axis, and then I have a point. Let's see, a point A somewhere here, right? So we are saying that this equation of the line passes through the point, right? And it's also a parallel to B. When is a parallel point? A parallel point can be on the line, or it can be something like this. So we can have this vector that we are talking about, B, to be something like this, which we are going to call it B, or it can still be on the line B, something like that. So that's what we are trying to do. So it's like now we have equation of the line which passes through this line, this point, and this point. Basically, that's what we mean. Right. So now that we know the equation of the line passing through the origin and not passing through the origin, let's look at some examples. Like, always practice always gives us the understanding of what I was trying to say. So let's practice and see what we are trying to do here. So if the position vector A is this, find the equation of the line which passes through A and the origin. So first thing that I need to recall is my position vector is equal to lambda A, because this one passes through the origin and the point A. Simple. So what am I going to get at the end of the day? What am I going to get at the end of the day? So I will show you how to write it in the parametric equation form. And then sometimes too, if you want to write it in a symmetric form too, we will learn how to write it in a symmetric form. So let's do it. So this is going to be lambda. Now A is minus 3i plus 4j minus 6k. Right. So this is what you are going to get. Now this is the same as minus 3 lambda I plus 4 lambda j minus 6 lambda k, right? So basically this is the parametric equation. This is the parametric equation. So let me name it here. Parametric. This parametric equation, we can also write it in this form. Let's say minus 3 lambda, right? And then 4 lambda and then minus 6 lambda, right? Since I'm putting it in this, I'm not going to include the ijk, right? So I can write it in this form. Now remember, we can also talk about r. R is a vector, right? Because we have this one here. So I can define that my r is equal to xi plus yj plus zk. So when I do that, then I can write this one too as x, y, z if I want to write it in this form. So it means that I can write this one as x, y, z. This implies that the first component is equal to the first component here. This is also equal to this, and this is also equal to that. So that is how we are working with. So this is parametric equation. Let me say this is in the vector form because it's like kind of vector, like this vector form. And then now we are going to use this comparison to write it in the symmetric form. So let me say this is the vector equation. Let me call it vector equation. So now let's write it in the symmetric form. So in the symmetric form, I'm going to find for x. So this implies that x is equal to minus 3 lambda, right? So what is lambda here? This implies that lambda is equal to x divided by minus 3. Here, the way we write the thing is very, very important. Here, I cannot write it. You see, in math, if I have something like 1 over 2 minus 2, this is the same as minus 1 over 2. Yes. But when you are writing this, because we pick some of the components, I cannot move the minus here. It should be here so that I know that this goes with the lambda, not the x. Very, very important. You need to pay attention to that. And then I have y, which is equal to 4 lambda. This is also going to give us lambda is equal to y divided by 4. And then lastly, can I shift something up? Yes, I can do that. Let me shift this one up small so that I can write my lastly. And then shift this guys Good. And lastly, my z, which is equal to minus 6 lambda, implies that lambda is equal to z divided by minus 6. So now I'm come to show you how to write it in the symmetric form. So symmetric form is, now you see that this is lambda, this is lambda, this is lambda, right? So it means that if this is equal to this, and lambda is equal to this, and lambda is equal to this, then this is equal to this is equal to that. So I'm going to have it in the symmetric form. X divided by minus 3 is equal to y divided by 4 is equal to z divided by minus 6. This is what we call symmetric equation, or in the symmetric form, or symmetric equation. Very important. So now we've learned three forms here. I just used one question to show you that. So I knew that there was my equation of the line, and then I knew a, so I just did substitution for a. I multiplied through by lambda to have the parametric equation, and then I wrote this one in the vector form by taking away the ij and then putting in this one. And I know that this is also a vector, so I can write it in this form and then have it this form. Then now equate this to this, this to that, this to that, right? And then I'm having something like this. And then with this, I can write it in what? The symmetric form. So look at something here. As soon as I want to form my A, you see the A? My A here is just minus 3i, 4j, minus 6k. That's what I'm saying, that it's very important how you are writing these guys here. So you see that always the vector which goes with the scalar here, the lambda, is always the one at the denominator here. We will do the second question, and we are going to talk about this one too. And you see that with this one, we are always going to see that B will be the one at the down, and this one will be the, let me say, the center, like I mean the center, right? Because this is kind of like the center is 0. So this is kind of, I have minus z naught minus, sorry, y x naught, and then minus z naught, but x naught is 0, y naught is 0, and z naught is 0, meaning that it's passing through the origin. Good. All right. So basically, this is what you are going to get at the end of the day. What is in the symmetric form, or is the symmetric equation? Let's look at this one too. Okay. A light goes through the origin, okay, the same thing, and has a direction this. Write the parametric form of the line. So I think I've shown you that, and write the symmetric form of the line. Good. So the same argument here, but this is in the 2 dimension. I mean, the k aspect is 0, so 2 dimension. So same thing, my r will be equal to lambda. It's not always that you need to use lambda. I can even change the lambda to t, right? So this one is going to be this. And then with this one, I'm going to have t times 2i minus j, and then multiply through by t, you have 2ti minus tj. So let's write it in the, so this is the parametric form. So as we said, parametric form, or the parametric equation. So for us to write it in a vector form, I'll let r of x to be equal to this plus yj. Now I'm stopping here because this is just ij. This one I added the z because this one was 1, 2, 3. So this is going to give us, now we are going to write this one too as xy. So it means that this implies that I'm going to have xy, which will be equal to 2t minus t. Is that right? So my x is equal to 2t. This implies that t is equal to x over what? 2. And then y is equal to minus t. This implies that t is, you cannot say that t is equal to minus y. No. What you can say here is t is equal to y divided by minus 1. That is very important with vector writings. So we are thinking, vectorly. So now this implies that x over 2 is equal to y over minus 1. So that as soon as I see this equation, because sometimes we can give you a question where we have it in this form, then maybe you will need to pick the d so that you can use the d to work. So as soon as I see this, I know that my vector d is 2I minus 2j. So it's very, very important. Let's look at question 3 and let's see what we are going to do here. Now, given the point A whose vector position is given as this and vector B this, find the equation of the line which passes through B and passes through A and parallel to what? B. So kind of this questions, you see, we have 2 points. So always you ask yourself, now which one is going with the lambda? The one that goes with the lambda is what we call the directional vector. When you say something is a directional vector, I mean, if I have a vector like this, directional vector is the one that's going with the vector, like showing us the direction where we are moving to. So we call it the directional vector, right? So the directional vector is the one which is parallel towards the line equation, because that's the one leading us. Good. So it's kind of like if I have something like a vector which is, let's say this, then if I multiply it by a scalar, I can just extend this line like this. Good. So this one, we know that we have 2 points. So this one is going to be something like, so let's look at the terms here. We have A and B. So I'm going to have A plus lambda B, right? Or I can use the vector form like moving up, moving up, moving up, and remove the down. It's also the same thing. So now I know my A, I know my B, because now B is the parallel one, so we should go with the scalar, which is lambda. So now let's do substitution, and I'll show you how to write this one too as well. So this is going to be 2I plus 2j, right? Let me put it in parentheses, plus lambda. Then this is going to be minus 3I plus 4j. This is kind of interesting. Now, what we just need to do is we need to, you see, for us to have a parametric equation, we need to have I and j. So this is what we are going to do. I'll expand this and have 2I plus 3j plus, no, minus 3 lambda I plus 4 lambda j. Let's group items. I have I here, I have I here. So I can factor the I out. So this is going to be left with 2 minus 3 lambda I. Do you see that? Yes. And then plus I have j here, I have j here. When I factor j out, it will be left with 3 plus 4 lambda j. So now this becomes the parametric equation, or the parametric form. Good. Now, and this is that. So now we want to write it in the vector form, right? So let me shift my equation. I think my space is too small. So now I want to write the vector form. So what I'm going to do is I'm going to define my R to be xi plus yj. Do we have how many? We don't have k, so I just leave it here. And then this is going to be xy. So what am I going to do here? Let me put the parametric down here so that I can have this space up there. So now, see what happens. Now we are going to have xy to be equal to, so xy is my r, which will be equal to this. So now this will be 2 minus 3 lambda and then 3 plus 4 lambda. So same thing, x is equal to this, y is equal to that. So this is going to give us x is equal to 2 minus 3 lambda. And then we have y2 is equal to, so let me finish that. Y is equal to 3 plus 4 lambda. Now this implies that, so let's look at what is going to happen here. here the movement is very important. I'll just move the 2. Don't think because this one is minus, so you are moving this guy to this side and move this one to this side. I mean, doing something like 3 lambda is equal to 2 minus x and saying that lambda is equal to 2 minus x over. No. Hold it the way it is. So what I'm going to do here is I'll move the 2 to the left. So I'm going to have x minus 2 is equal to minus lambda minus 3 lambda, right? And then finally, I'm going to have something like this. So I'm going to write this one as lambda is equal to x minus 2 divided by minus 3. Good. Let's look at this one. So this one too is going to be, this one implies that y minus 3 is equal to lambda, and then lambda is equal to, so what is in front here is 1. So I'm going to have, oh no, what is in front here is 4. So I'm going to have lambda is equal to y minus 3 divided by 4. So look at something here. If I want to call for my vector b, okay, let me finish it up. So now x minus 2 divided by minus 3 is equal to y minus 3 divided by 4, because lambda is equal to this and lambda is equal to this. So it means that this is equal to this. Now, if I want to look for my vector b is the one down here. So minus 3i plus 4j. Then if I want to look for my a here, my a, I think I make a mistake somewhere. Where is it? What was a? A is 2. Okay, I think it was coming from here. So this one's supposed to be 2 because we have 2 here. So this one's supposed to be 2, and then it means that this one will be 2. Oops, 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 oops. And then which one? This one too will be 2. So this one will be 2. This one will be 2. No. Which one am I cleaning? So if this one is 2, okay, this one is 2. Okay, so this one rather supposed to be 2. So this one will be 2, good. And this one will be, no, this one should be 4. And this one should be 2. And this one should be 2, good. So the down here, always the down is the one with the scalar, right? So the one with the scalar means that my b is going to be minus 3i plus 4j, and my a will be the one here. So I'm going to have, it is x minus 2, so it is 2, 2i, 2j. So for example, if this one is plus, then it means that my a is going to be 2i minus, because this is plus. Good. So that's what we just need to have here. So this is what we are going to get from question 3. So this is the symmetric equation. This is a symmetric equation. Let's look at question 4. Let's do more on question 4. So question 4 too, I think similar, but this one is in the 3D form. So let's pick our functions. So let's assume that let me say vector a to be equal to 0, 1, 1, meaning that this is j plus k because the I direction is 0, right? So my vector, which is a plus lambda b. Now I'm adding the b to this because b is parallel, right? So this is a plus lambda b. So always check before you do it. So this is going to be I plus k plus lambda 4i plus 2j minus 5k. So let's go through quick. I plus k plus 4 lambda I plus 2 lambda j minus 5 lambda k. Group items, we have 4 lambda I plus 1 plus 2 lambda j plus 4 lambda, no, plus 1 rather, 1 plus, minus 5 lambda k. So we are grouping line terms. We have only one I, so it comes here. Then we have this j, and this j. So when I factor j out, it will be 1 plus 2 lambda. And we have k here, k here. When I factor k out, it will be left with 1 minus 5 lambda. So what is the, so this is the parametric, right? Now we know it. Then this now becomes, since this is ijk, this is x, y, z. So, and this is going to be 4 lambda. Let me write it bold. 4 lambda, 1 plus 2 lambda, and then 1 minus 5 lambda. So let's go. X is equal to 4 lambda. This implies that lambda is equal to x divided by 4. So you see that here minus 0 because the x here is 0. Good. Then when you pick the y is equal to 1 plus 2 lambda. This implies that y minus 1 is equal to 2 lambda. And this implies that lambda is equal to y minus 1 divided by 2. And then lastly, z is equal to 1 minus 5 lambda. Z minus 1 is equal to minus 5 lambda. And lambda is equal to 5 minus 1 divided by minus 5 lambda. So now we can conclude that, I'm doing the conclusion up here. Let me use the blue. We can conclude that x divided by 4 is the same as y minus 1 divided by 2, which is also the same as z minus 1 divided by minus 5. All right, so that is what you are going to get. And we can see from here that these are the coordinates for the b. Where's the b? Here. So you can see 4, 2 minus 5. 4, 2 minus 5. And we can see 0, 1, 1. 0 and 1. So that is what, like, way you can see. We will solve some objective questions and I'll be showing you the tricks tools too as well. Okay, so let's do question 5, then you try question 6. Okay, let's do question 5, then I will show you question 6, then you will just try it. So find the vector equation of the line that passes through this point and is parallel to, okay, nice. So you see that now we have 3.1, 2, 3. But basically, this is the first point, and then we want to work around this. So what we are going to do is, we need to combine these two vectors, this and that. So this is equal to small b minus small a. Now small a will be 2i minus k, yes, and small b will be 5i plus 2j. So let's do that. So this is going to be 5i plus 2j minus 2i plus 2i minus k. So 5i plus 2j minus 2i plus k, and this is going to give us 3i plus 2j plus k. So now we're able to find this. So what will be the things that we need to do here? So now let's assume that c is equal to 20 minus 1, which is 2i minus k. Then we are going to have our vector to be c plus, let's say, t, and then a, b, vector a, b. So that's what we are going to get. So instead of getting just a b here, we needed to form vector a, b before we can write this. So you see, when you solve more questions, it actually gives you the chance to see the other options of, the way of putting the questions. So now basically we can do this now. So c is 2i minus k plus t, and this is 3i plus 2j plus k. So we are going to have 2i minus k plus 3ti plus 2tj plus tk. Group items with I, j, and k. So you are going to have 2 plus 3ti, and then we don't have j, so there is only one j, so 2tj, and then plus minus 1 plus tk. So this is the parametric form, right? Parametric form. Then we can now move it to what is called the vector form, and then from the vector form we can talk about the symmetric. So this one, vector form will be x, y, z, which is equal to 2 plus 3t, 2t, and minus 1 plus t. So this implies that x is equal to 2 plus 3t. This implies that x minus 2 divided by 3 is equal to t. Then we have y is equal to 2t. This implies that y divided by 2 is equal to t. And we have z, which is equal to minus 1 plus t. And this implies that z plus 1 divided by 1 is equal to t. And then finally, we have everything equal to that. So we are going to have x minus 2 divided by 3, which is equal to y divided by 2, which is equal to z plus 1 divided by 1. So as I said, if this one is plus, it means that it's minus minus. So we can see that our coordinate for AB, vector AB, which is 3, 2, 1 is here. 3, 2, 1. And then our C, which is 2, 0, minus 1 is here. 2, 0, minus 1 is also here. So basically, this is very simple to work with. So try this question and put it in the comment section. Leave your final results in the comment section. I hope we can do it. It's just very simple. I'm not going to explain it, but try and find your way out. So we want to find the equation of the position vector parallel to Q. P is given, Q is given, and then they've given you A and B. So it's just P and Q, but P is in this form, Q is also in this form. So try and do it and leave your final results in the comment section. See you in the next video where we are going to talk about equation of the plane, and then I think probably we need to talk about the intersection of a line and a plane. See you.